Hi, welcome to Functional Justin episode 10. In this episode, we're going to make use of the WriterT monad transformer implemented in the last video, and we're going to combine that with either. So the WriterT either will give us the ability to write a program that can handle errors and also accumulate a log of its progress. So the expression evaluator is a program I've been working on throughout this series to demonstrate various concepts, and it lends itself well to this one because essentially we're just adding a capability to an existing program. We want to leave the original program as unchanged as possible and show how we can sort of augment a program by introducing a monad transformer. Alright, let's get started. Okay, so we're all set up to begin the coding, and let's just review what our starting point is. So I have this program called a val expression, and let's look at the various things that make it up. So first of all, we have a Scala 3 enum, which creates our abstract data type. And this data type represents all the different operations that the program can do. So we're essentially making an interpreter that can run an expression tree and produce some kind of result. And it's basically limited to arithmetic expressions. But you can imagine that this could be part of a more complex program, doing some more interesting business-oriented stuff. But this is just complex enough to show how we can use these effects to our advantage. The most complicated part of this program to understand, and there's a whole video on this, is the idea of context functions. So the return type of this function is simply an either. So there's a number of val errors that we can return if the expression fails, and then the actual return type, which is going to be a number of type A, or we're going to have a numeric instance of type A. But this part is new to Scala 3, and what that means is that this is not just an ordinary function, it's a function that has an implicit variable of this type that we don't want to pass all the way around all our functions. We just want to be able to summon it whenever we need it. And the type of the context is an environment. As you can see here, an environment is just a map of strings to A's. In other words, that's going to be our symbol table. So when we're evaluating expressions, you can look up strings and map them to values. And then the program itself is just a match statement, which matches each type of expression that we support to some kind of function that runs that expression. And then we've got these functions here. These are not actually complex enough to be functions in their own right, but if our program gets more complicated, it will be thankful that we broke it down this way. You can see that the expression evaluation itself is very simple looking. But in fact, each of these operators is implemented by making instances of numeric. So this is actually doing an applicative application of an either and a numeric. So we've got quite a sophisticated amount of stuff going on here, but our actual program looks quite simple. And that's one of the advantages of both context functions and being able to put behavior into your type classes like we're doing. So if I run the program, what you'll see is we've got this expression here, which consists of adding z to the sum of a raw value 10 with the variable x and the variable y, right? So not a very exciting expression, but you can see that it evaluates the right answer. It gives it to us in a right either, and then the value of that is 45, which is correct. And then this example here gives us an example of division by 0, right? Now I'm just going to comment that one out because we're not going to be as interested in error handling in this video as we were in the last one. Alright, so what we want to do is, remember in the last video we made a type class called writer. So we're going to want to import that. We're going to import the data type of writer. And there's also a monad instance of writer, which will be in this class here. So this was developed in the last video, so we've got an instance for the writer monad. So that means that we'll be able to use the writer monad in our program. So what do we need to change to take advantage of it? Well, the main thing we've got to change is the actual return type of our expression. So the return type is going to change from being a val result either. We're going to make a new type called the val result w, just to distinguish that it has a log with it. And that's going to be parameterized by type A. And what we need to do is introduce the WriterT, and the WriterT has 3 arguments. So the first one is going to be the eval result, like that's so. Then we need a log type, and that's going to be a list of strings. So as we proceed through the computation, we want to be able to add strings to our log and then have them printed out as a list at the end. So we've changed the return type, or rather we've made a new type that we can use as a return type. The next thing we want to do is go down to our expression evaluator code here. So if we want to change the return type of our function, this is the starting point. So with env is essentially the return type of our program. What we want to do is change that to be the data type we made at the top, which was eval result W. So this one is going to become eval result W, parameterized by A. Alright, so that will break everything because our program is not capable of handling writers yet, but we'll fix all that. So first of all, why is it broken? Partly it's broken because these are now the wrong types. So this, instead of being just a write, it really needs to be a WriterT. So remember from last time, when you want to lift something from being the nested monad to being the monad that's inside the transformer, then you have to use the lift command. So we're going to use lift, and that will lift that into the correct type. Now there's problems with type inference with WriterT, as I mentioned in the last one. So what we need to do is just help it out. So the first parameter is the monad type, which is an eval result, and then the second parameter is a list of strings, and then the third parameter is going to be A, which in this case is going to be parameterized above there, like that. Okay, so that's fixed that one, and then these runs are all broken. We don't have an instance of numeric for WriterT, so that's what I'm going to have to implement next. Oh yeah, so this error is that I didn't import the monoids yet. So from the last video, you might remember that you have to have a monoid instance of your log type, and we do have a monoid instance of list string, so we just need to make sure that we import that. Okay, so that's fixed. And the next problem is all of these, so that to fix all of those we need an instance, and this one down here can be fixed in the same way as this one. It needs to be lifted like that. And the same with this one. So these just need to be lifted, and then what happened there? Too many brackets. There we go. Alright, so the next thing we need to do is to make a given instance of WriterT numeric. So let's just go up to what we have already. We need an instance of numeric for the return type, for the eval result return type. That's what we don't have anymore. So what we do need is to create that instance. So this is going to be a WriterT of an eval error W. Sorry, just an eval error. Sorry, in fact this whole thing could be eval error W. Sorry, eval result W, like that. And let's see, it does not have the same kind as its bound. Okay, that's correct. So eval result W with an A. Right, what we need to do now is, this is complaining that we have 5 unimplemented members, and that's because all the members we implemented are now for the wrong type. So we need to fix that. So this would be val result W. That can remain the same, I think. Let's see. Found A, required any. That's probably not correct. I think that error is wrong, so I'm just going to ignore it and come back to that one. For this one, we can just do val result W, and that should be enough to make everything work. Same for this one. Same for this one. And same for this one. Alright. So we've got a couple of errors left. What's this one? Okay, so what I needed to do there was get the value from out of the eval result. Remember that this used to be an either, so we could match on it. But now it's an either inside of writer, so I had to use the value command to get the either out, and then we can match on that. So now that one's fixed as well. Now the problem here is that we just need to lift this because this is an either, whereas we now need it to be a WriterT either. And that one's done too. What's the problem with this one? So this one is actually just that we didn't bring in all of the types we need, because this one requires functor. But I think it would actually be nicer to use map2. That was only using flat map for legacy reasons, so we can just change it back like that. Okay, so that's the conversion, and all we need to do is run that now, and hopefully you can see that what we got was the correct answer, 45, and we also got empty list. And the reason we got empty list there is that's actually our log of the computation, but there isn't anything in it because we didn't tell it anything yet. So remember that WriterT has a tell command. It lets us actually add logs to the computation while it's in progress. So let's add some log, and then we'll have something more interesting to look at. Let's start with the var implementation. So when we implement var, we're going to call the handle var function. So what we can do is just tell with, remember tell with lets us add a log that actually is able to look inside the result. So we can say, now the log is going to be a list of strings, so we're going to create a string, and we can add a log that just says that we handled the var, and the var is ID, and the value is A. Right. So now we can run the program. Alright, so now you can see that our log contains some things that actually happened. So during the computation, we can see that it handled these 3 variables. Z was 22, X was 7, and Y was 6. Okay. So tell with is useful because it lets us add a log to a computation that's in progress, but it lets us look inside the result of the computation and include that in the log. Now what I would like to do is do exactly the same thing for these more interesting expressions. For add, divide, subtract, and multiply, these ones are different because they have 2 arguments. So we can't use tell with here because what I want is I want to be able to look inside the result of this computation, which is taking 2 effects, FA and FB. At some point it's able to extract the A and the B and then add them together. Now what I would like to do is, once that computation has been completed, I would also like it to be able to write to the log. So to make that possible, it's not possible with the tools we've got available. So I'd like to make a helper function that just combines the functionality of map2. Remember, the point of map2 is it lets us combine 2 effects and use them as parameters. And I'd like to do something like tell with, but that's able to look at 2 parameters and a result. So we'll just implement that here. I mean, you could put it in a library of some kind. You could add it to the WriterT implementation, but for now, let's just write it as a function. So I'm going to call it mapTel2. And the reason for the name is it's a combination of map2 and tel. We're going to need some type parameters. So we're going to need 3 pure values, a, b, and c. And we're going to need a high-kinded type f. That will represent probably our applicative instance that we need so we can do map2. And then we'll have w, which is the type of the log. So our input parameters, we're going to need an fa, which is going to be a WriterT, and that's going to have type fwa. Then we're going to have a second effect called fb, which is going to be a WriterT fwb. And when we do map2, we need a function that takes an a and a b and returns a c. Right, so I'm going to call that fabc, and that looks like this. A, B gives you a C. And then we want a function that is going to be our log function. So it's going to be able to look at the input and the output and create a log entry. So the types there, I'm going to call it fabcw. And the types here, we're going to have an A, B, and a C, because we want to look at the input and the result. And we're going to create W, which is a result type. Alright, and we're going to be using some stuff. So remember that using is the Scala 3 way to bring in implicits into a function, into function parameters. We're going to need a monoid, so we'll call that M, and the monoid is in type W. We're going to need an applicative, so we'll call that F, applicative in F, and that's it. And then we need a WriterT. Actually, we'll just use monad for this for now. It could be applicative, but monad is actually fine. And then we'll have a return type is an FWC. So there's a lot going on in the types there, but essentially what we want to do is think of this as being a simple function that takes 2 inputs that are effects, an FA and an FB. And we're writing this general enough that it can work with any monad. Right? It doesn't have to be an either. But it does have to be a WriterT, and it does need a monoidal log. Alright, so what's the code look like? Well, let's start off with, we're going to take the FA, we're going to get the wrapped monad inside it. Remember, it isn't either, but we don't know that, and we don't have to assume that at this stage. We're going to call map2 on that. The second parameter is going to be the FB wrapped value. So we're essentially calling the map2 on the inner monad, on the either. Alright, so the result of that, we're going to get back the log of A, and then we're going to get the log of B and B. And then what we need to do is apply our function to those values. So FABC with AB gives us the result of the computation. Then we can calculate the new log value. We can call the user's passed in logging function FABCW. Now the next thing we want to do is look at the previous logs of A and B, and we need to append them together because we don't want to lose any previous logs that were there. So we'll just call this previous, and then I'm going to use the monoid to combine the logs of A and B. So that's AL and BL. And then the final thing we need to do is combine everything together. So we'll take the monoid again. We're going to combine the previous log with the new log, which remember we got from the user's function, and then the return value is C. And that's everything we need. And then what we need to do is return a WriterT. And remember that R here is actually the inner monad. So in our case, that would be the either. So then we have to wrap it up like that. So not a super complicated function. It does have a rather interesting type signature, but I think that should do everything we need. So now we can go to the add function, And now instead of map2, we're going to call our map2tel function. What did I call it? Maptel2? Did I call it that? Yes, I did. And then we want to fix the right parameters. So we're having fa, fb. We have a function that takes an ab. And then the last thing we want is to pass a function that prints our log. So let's say we have a, b, c, and we want to print a log entry for that. So that's going to be a list, and then a interpolated string, and then we can put something in. So let's say we'll just print the total so far, which is going to be c. And then we can say that we added a to b, added a to b. Alright, so that works. And then we need to do the same for each of the other operators. So this one is division. So this just needs to be a divided by b. And we've got to rename these. So that's fa, fb, fb. And then this one is going to be like that. Oh, I just need to rename this. So divided b by a. No, I don't need to reverse those, sorry. Divided a by b, and then this one subtracted a from b, and then the last one multiplied a by b. There we go. So now we can see if it works. So let's print our expression. There we go. So what we get at the bottom is, you can see we still got our variable lookups as they were processed, and then we've got our running total here is 13. We added 7 to 6, and then we added 10 to 13, giving 23, and then we added 22 to 23, giving us 45. So there you go. We've successfully added logging to our program. So now we're doing logging and error handling both at the type level. Just going to re-enable the error handling just to show you that the error handling is completely unaffected by adding logging. And one thing you should bear in mind when using the WriterT is that if the computation fails, and that is the inner monad, if that one fails, then the log will disappear, because the log is kept in the success part of the computation. So as soon as the computation fails for some reason, the log is gone, and you just get the either. You just get the left, in our case. So that's something to bear in mind. If you wanted to keep the log under failure as well, you'd have to use a different kind of data type. Okay, so that's the end of the video. I hope you liked it, and stick around for the next one. Hit the subscribe button, and hit the thumbs up button. Tell your friends that this was a good video to watch. And one final note on monad transformers. We're going to be looking at more advanced techniques for handling what you would call multiple effects, and there's various ways to handle it, including the MTL library in Cats or Zio. So I just really did this as an academic exercise, something some people might find interesting, and you know, it shows you that monad transformers are not something to be scared of. Thanks a lot. See you next time.